Hi there, this is Wenjie, Deborah at Greptime. In our previous video, we showcased how GreptimeDB supports PromQL and can serve as a Prometheus long-term storage backend. Now, Prometheus is widely adopted across industries for data monitoring. However, it mainly focuses on metrics data, making it less suitable for handling logs. This limitation makes it challenging for use cases that require both metrics and log data for comprehensive insights. That's where GreptimeDB steps in as a unified database, providing the ability to handle both metric and log data simultaneously. In this demo, I use Vector to efficiently stream both types of data into GreptimeCloud. I'll also show you how to use pipeline to pass and transform unstructured log data into structured forms, making it easy for more precise queries. Okay, so let's get started. All the source code and example config files in this demo can be found on GitHub demo scene. Here, select Vector Ingestion. You can also follow the instructions here. The very first step is to sign in to GreptimeCloud and create an instance. You can log in here, click sign in on our website, log in with your Google or GitHub account, or sign up with your email address. Since I've already got an account, I will log in directly using my account. Okay, now we are on the home page of GreptimeCloud. Let's hit Create New Service and let's select Hobby Plan, which is completely free with no credit card info needed. Here I will name my service Log Demo. You can also generate one randomly if you like. I will skip the description and hit Next Step. Okay, just a few seconds and the service is up and running. Hit Connection Information. Here you can find the hostname, database name, username, and password. Save it and we will use it later in this demo. So the next step is to install Vector. Open the terminal and let's use sudo to install. Sudo docker. Okay, successfully installed. Okay, now let's go to desktop and create a new folder for the config files. Now let's create an empty config.toml file in it. The example TOML file can be found on the demo scene as well. This file defines sources and sinks, essentially telling Vector where to collect data from and where to send it. First, we have host metrics here. This source collects system metrics like CPU usage, load, and memory every 5 seconds. And next is the Apache logs, which generates 100 simulated log entries in the Apache common format, 1 per second. And moving to sinks. The metric sinks take the data from host metrics and send into GreptimeCloud as a specified endpoint. The log sinks receives data from Apache logs and forwards it to GreptimeDB as well, using a predefined pipeline called GreptimeIdentity to structure the logs into demo log table. And finally, structured logs is similar to the log sync but uses a different pipeline called Apache Common Pipeline. This pipeline processes the raw log data and stores it in the demo structured logs table, allowing us to run more detailed queries. With this configuration, we're able to collect both metrics and logs and send them to GreptimeDB, transforming logs into structured data for better analysis. So when copying this code, make sure you replace all the connection information with yours in the sinks. Okay. Copy the code into our config file. Okay, let's copy the code here. And let's replace all the information. Okay, all done. Then let's create a pipeline.yaml file in the config folder. You can also see the pipeline YAML file in the repo scene here. This pipeline YAML file uses dissect to parse Apache logs into structured fields. The dissect processor splits log data into parts like IP address, user, request time, HTTP, etc. The data processor formats request time into a queryable timestamp. You can see that certain fields are typed and indexed. For example, request path has full text search enabled, and the status code is set as an integer. So this setup allows us to query unstructured log data efficiently in GreptimeDB. Okay, now let's copy the code into the file we just created. Okay, now let's create an Apache common pipeline. You can see the command on demo scene readme here. Scroll down to the bottom menu code, and you can see the command for creating Apache common pipeline. So here, don't forget to update the DB URL, username, DB name, and password. Copy the file, and I will replace with my connection information. Okay. Now let's head to the web dashboard in GreptimeCloud to see if the pipeline is ingested. Here you can conduct SQL queries. Let's run this command. Great, you can see we have our YAML file here, Apache common pipeline. Here, you can view the details of the pipeline. Now that you have all the config files needed, let's ingest the data into GreptimeCloud. You can also find the launch vector command here. So this command runs a vector container with a custom configuration. rm deletes the container when it stops. And the second line mounts our local config TOML file to the container, making it read-only. And the name vector names the container vector. Finally, the last line specifies the vector image and config parse. This starts vector with our config and automatically cleans up when done. Okay, copy this. Okay, let's run it. Again, it will need your password. Great, you can see that data is being ingested. With our previous setting, the log data will be simultaneously written into GreptimeCloud as demo logs for the raw data and demo structured logs for the parse structured data. Okay, let's head to our dashboard to check it out. If we go to the dashboard again and refresh the page, you will see that there are already tables in the database. Those are data we just ingested. Then you can use some SQL queries to query the data. Let's try doing some queries. Okay, we can run the line separately. Run line 2, and you can see the pipelines. Okay, let's try and run line 5 to show the metric data. Okay, yeah, here's the result. Great. And then you can also show the raw logs data. Run line 8. We get result 2. You can see here's the raw data which contain a message string here. Yes, okay. Then let's see how we got the structured logs data. Run line 11. Yeah, you can see that the values are passed into different columns, and it's easier for data query later. And you can do some more specific data query like this. Line 15 to 17 shows demo log schema and full text index. You can see the schema. We can see from the create table that we have full text search enabled for request path. And for the last line, we run it. It retrieves rows from demo structured logs where the request path field contains work or metrics. That shows that GreptimeDB also have the ability for fuzzy search. That's all for today's demo. We've successfully set up Vector to collect both metrics and logs, passed our log data using GreptimeDB's pipeline feature, and explored our structured logs using SQL queries. This setup demonstrates how GreptimeDB can unify metrics and logs in one place, making it easy to analyze and search data efficiently. You can find more product details on our website at greptime.com. We encourage you to explore GreptimeCloud, play with all the functions, and use it as a unified database for metric and log data storage. You can always find us on other social media accounts such as LinkedIn, X by searching GrepTime. Note that our database as a service product GreptimeCloud is now open for free with no credit card info required at all. You can register using the link below. Just give us a try and we are looking forward to your reply. So see you next time.